Hello class, and welcome to lesson 6.3, solving equations in the form a to the n equals x to the n equals a. So today we're taking a look at some exponential functions, ladies and gentlemen. Okay? And it's exponential when you see an exponent, right? So let's take a look at what it says here. First of all, equations in the form x to the n equals a, where n is a whole number, can be solved by taking the nth root of both sides. I'll give you the example in a. So for a, ladies and gentlemen, it's x squared, so n in this case equals 2. So if I rewrite the question, okay, I'm going to take the nth root of each side. So I'm going to take the square root of one side, and whatever I do to one side, I take the square root of the other. So x is going to equal plus or minus 5. So there's two solutions there. X equals negative 5 or x equals 5. All right? That's what happens when things are even. Okay? So you're going to have what's called the plus or minus at the nth root. Okay? But when the exponent is odd, like in example B, it's going to just be the nth root. Okay? So when we take a look at this, there's going to be no plus or minus is what we're taking a look. So I'm going to rewrite the question. Okay? Currently it's x cubed. How do we get x by itself? We take the cubic root of it. Whatever you do to one side, you do the same to the other. And the cubic root, so the cubic root of x cubed is x equals the cubic root of 64 is 4. On a side note, ladies and gentlemen, just recall that if I give you this example, x cubed equals negative 64, you're going to take the cubic root of both sides. And yes, you can take a cubic of a negative, just not of a square of a, you can't take a square root of a negative. So it's going to be x equals negative 4 in this case. All right? Okay? And again, look for, you probably have a cubic root button in your calculator. Okay? All right, next one, C. Taking a look at C, it's not as easy because the variable is buried in a binomial. Okay? So the first thing we have to do is realize, hey, this x squared is getting in our way. So I'm going to go x minus 4. I'm just going to rewrite the question for a second. Okay? And we got to get rid of the exponent first. So we're going to take the square to the left side. Whatever we do to the left side, we've got to do the same to the right. Because remember, squaring and square rooting are opposite operations. So you're going to have x minus 4 equals plus or minus 9. Okay? To get the variable by itself, you're going to have plus or minus 9 plus 4. Just realize, ladies and gentlemen, that there are two cases here. Okay? So x equals positive 9 plus 4, or x equals negative 9 plus 4. If you have the positive 9 plus 4, you're going to have an answer of 13, which is one answer. And the second answer is going to be negative 5. So there's two solutions there, ladies and gentlemen. All right, let's try this next one. Okay, taking a look at x plus 2 to the power of 5. Again, we want to get that variable isolated. So we first of all have to deal with the exponent, and it's the exponent of 5. So we want to take the nth root of both sides. You're going to take the fifth root of this. Whatever you do to one side, do it to the other. If you need help learning in your calculator how to find the fifth root, let me know. Okay, usually you have an x to the root of y, or y to the root of x button, which will do that for you. Okay, so look for those buttons on your calculator. All right, so what do we have left? We have x plus 2 on the left side, and I guess you don't technically need the brackets because that's all there is on the left side. So just erase them, hopefully. There we go. So we're left with x plus 2, and in your calculator, plug in the fifth root of 243, and you should get 3. Okay, and then to solve it, ladies and gentlemen, you are going to know that it's going to be x equals 3 minus 2, okay, and x equals 1. Notice because it is an odd It's an odd exponent, ladies and gentlemen. There's only going to be one solution. Okay? When there's an even, there's going to be two or more. All right. Let's take a look at our last example here today. Use a graphing calculator to solve x to the third equals 12. Well, if we tried to do it by ourselves without the technology, okay? If we try to do it by ourselves, what do we need to do? We need to get x by itself, so you're going to take the cubic root, and whatever you do to one side, you do the same to the other. So if you get a calculator, oops, let me go grab mine, ladies and gentlemen, and I'm just going to go and plug in the cubic root of 12, and I get an answer. I got to round it, and I'll say 2.289. Hopefully everybody's doing that on their calculator. Okay, but it says to use the technology. So I'm going to go to my graphing calculator, and you can use any online graphing calculator. I go to y equals, and I already have my x cubed in there. I'm sorry, back the truck up. I forgot to introduce how we do this. So let's go back here. The instructions are to plot both sides on the equal sign. So for y1, that's going to be equal to x cubed. Okay, and for the second equation, that is 12. And we did this back in the exponential functions unit. Hopefully you remember this. Okay, and then what we're going to do is once we've got both of them plotted, we're going to use the intersection function under the calculate menu. All right, now we're back to the graphing calculator. Oh, did I actually close it? I'm sorry. Oh, no, there it is. Okay, so I already have my one equation entered, and I need to put in 12. Sometimes you might have to adjust the window, guys, but I fixed it so you can see the point of intersection. So to do this, you're going to press second trace, which is your calculate menu. Look for the intersect button, which is 5. Make sure it's flashing on one of your equations. Hit enter. It should go to the other one. Hit enter. It says guess. And there's your intersection. So I'm just going to capture that quickly. Right here. Okay, and hopefully that'll come in nice and sweet there. Okay. So notice, ladies and gentlemen, well, it depends on how far it's been rounded to, but your intersection point is there. So that's your x value when y is 12. All right, here is your homework, ladies and gentlemen, page 118, 119, 1 D, E, and F, 2 A, B, C, 8, and 10. Thank you. Have a great day.